Okay, today we're going to be building onto the material that we worked on yesterday, the 5 laws of exponents. If you still haven't managed to get those memorized or haven't looked at your homework yesterday, you're already digging yourself an early grave for this unit, but you're going to need that same material again today and every other day as we go forward. But today we're going to be looking at combining terms that have exponents. So obviously you need the laws of exponents from yesterday. Okay. Now, we've got different sets of rules, okay, depending on what type of math a problem has you doing. Okay, so if a problem has you adding or subtracting, okay, terms that have exponents in them, there's a certain set of guidelines that we have to make sure are there, and then rules that we have to follow. Okay, so 3 conditions that must be met in order for us to be able to add or subtract terms. Okay, first off, if you want to add or subtract 2 terms, it must be the same variable or the same group of variables. Must be the same variable or the same group of variables. The second thing that absolutely has to happen if you are trying to add or subtract 2 terms, the variables that you are working with or that the problem has in them must have the same exponents. The variable or variables must have the same exponents. And the third rule that absolutely has to be met if we are going to try to add or subtract terms, and that rule is that if fractions are present, just like it has always been back into your late days of elementary school, you must have common denominators. If fractions are present, they must have the same denominator. Okay, so the bottom line is anytime you run into a problem that has addition trying to happen and there's variables involved, you need to go through this mental checklist and make sure that all 3 of these things are correct in the problem before you try to add or subtract. If you add or subtract and any one of these things are wrong, it is pretty much guaranteed that you're going to end up with the wrong answer. Okay, so let's take a look at some examples, okay, that go along with these. And this is just to kind of reinforce what you're looking at. We're not looking at the actual examples yet, okay, so you can probably skip copying this down. But the way this says, if you apply these 3 rules, okay, guys, the only thing that can be added or subtracted to or from an x is another x. The only thing that can be added or subtracted to a y cubed is another y cubed. The only thing that can be added or subtracted to an xyz is another xyz. Okay, and you can make this as exotic and as far out as you want. Okay, the only thing that can be added to an x to the 5th y to the negative 7th is other x to the 5th y to the negative 7th. Addition and subtraction is very, very picky about things. Okay, so basically your things need to be, for lack of a better way of putting it, they need to be identical. You got to have the exact same stuff adding to the exact same stuff. That's the way it works. Okay, let's look at some specific examples that go along with these rules. Okay, now if you kind of boil those three little guidelines down, it's really pretty simple. You got to have the same variable or the same group of variables that have the same exponents and have the same denominators. Okay, same variables with the same exponents with the same denominators. Okay, if you have that, then you can add things together. Okay, so have a look at this term. This is called a polynomial. Okay, for those of you that may have lost or don't know that term, polynomial. The prefix poly means many, and nomial means an expression with terms. Okay, so what we have here is we have a many-termed expression. There can be any number of terms being added or subtracted together in a polynomial. This one happens to have 4 terms. Okay, now look at the terms in this polynomial. Do you see any terms that can be combined? Things that we would consider like terms that could be added together or subtracted? Okay, yeah. Okay, there's some things right there. We've got some y's, sitting right there. And more specifically, they are y to the firsts. What do y to the first want to add or subtract with? Other y to the firsts. Now, since we happen to pick on the y's first, okay, that's okay. Okay, just remember that anytime you look into a polynomial, any sign that you see belongs to the term that follows it. Okay, so this isn't just a 3y, it is a negative 3y. This isn't just a 10y, it's a positive 10y. Okay, the signs belong to the term that follows them. Okay, so how many y's do we actually have? There's negative 3 of them there, and there's positive 10 of them there. How many is that? It's 7, but remember, if your signs are different, subtract the values and keep the larger of the two signs. So 10 minus 3 is 7. What's the bigger number, the 3 or the 10? The 10's bigger. So we're going to keep its sign. So we will have positive 7y to the firsts in our answer. Okay. All right. Is there anything else in there that we can combine? Anything that would be considered like terms? Yeah, we've got some x's. Here are some x to the firsts. And here are some more x to the firsts. Okay, so let's look and see. How many x to the firsts are there? This is positive 2 of them. This is negative 4 of them. Positive 2, negative 4. How many are there? 2, negative 2. Remember, if the signs are different, subtract the values, keep the larger of the signs. 4 minus 2 is 2. Which one's bigger, the 2 or the 4? 4 is bigger, it's a negative, so we're going to get a negative 2 x's, and then we decided we had a positive 7 y's. Now, is it incorrect if you write them backwards, if you'd have listed the y's first and then the x's? It's not incorrect, but you won't see it written that way. Okay? When it comes down to the variables, it's typically written in alphabetical order. Okay, you get the stuff that's toward the beginning of the alphabet first. You're going to get A's first, and then B's, and then C's, and then all the way down to Z's, and then you'll have numbers. Okay, stuff that doesn't have a variable, it'll come last. Okay, so anyway, there you go. Negative 2x plus 7 is exactly right. Okay, let's look at another one. Okay, we have another polynomial. Let's look and see what's in this one. Okay. What do you see in these terms that might be considered like terms, stuff we could add up together? All the d's, can all these terms be added together? Okay, they're all d's. Okay, well, what's the rule say? It's got to be the same variable or the same group of variables. That's exactly it. We have d's. They're all d's. What's the second thing say? The variable or variables must have the same exponents. Do we have that here? No, we've got a little bit of difference in the exponents. When it comes down to addition and subtraction, it's got to be the same variable or the same group of variables that have the same exponents. So the rule here is going to be the only thing that you can add to d to the firsts is other d to the firsts. So those two guys would be considered like terms. We could put those together. And let's see, how many d to the first are there? 15 of them, negative 9 of them. How many are there? 15 minus 9, there's 6. Okay, so there are 6 d to the first in our answer. It'll be positive. Okay, because again, the signs were different, so we're subtracting 15 and 9, keeping the bigger sign. 15 was bigger, so we get a positive answer. Okay, the only thing that can be added or subtracted to d squareds is other d squareds. So do we have any other d squareds? Yeah, there's 10 of them down here, absolutely. Okay, we have negative 13 of them. We have positive 10 of them. So how many are there? Negative 3. Signs are different, so we'll subtract them. 13 minus 10, 3. The 13 is bigger, so absolutely we'll keep the negative sign. So there'll be negative 3 of them. Negative 3 d squareds, positive 6 d's. And again, it would not be incorrect if you wrote the d to the firsts first and then the d squareds last. Okay, but again, just like there's a kind of a recognized order, we write things in alphabetical order. If it's a tie in the alphabet, like we have here, D and D, typically the highest powers are written first, then the next highest and the next highest until you run out. Okay, so if this were our answer choice, we would see a negative 3d squared would be on the lead term, and then positive 6d's on the trail term. Okay, let's look at another. Okay, another 4-term polynomial. Okay, well, let's have a look. Typically, what I usually do on these problems is I look from left to right. I just start off with the lead term and go, okay, I've got some ABCs. Okay, what can I add or subtract with ABCs? Other ABCs. Okay, so let's look and see if we have any more. All right, now this guy, negative 4, the second term here, negative 4, it says BAC. Now I wondered, is this the same term, or is this something different because everything's rearranged? Okay. Well, let's look back at the rules here real quick. You have to be the same variable or the same group of variables. Do we have that? This has 23 has an A and a B and a C. Does negative 4 have an A and a B and a C? It appears to be the same group, even though the group is out of order. But it does fit the first rule, where you have to have the same variable or the same group of variables. The second rule says the variable must have the same exponents. This is A to the first, B to the first, C to the first. Okay, does negative 4 have that? A to the first, B to the first, C to the first? It sure does. The last rule says if fractions are present, they must have the same denominator. We're not looking at any fractions. So this 23 is an ABC. Is negative 4 also an ABC? It is. Even though they didn't put it in the order that we would like them to have done that, it is still the same term. What about this negative 10 term? Should I underline it as well, or is it going to be a different thing to combine? It's got to be the same again, because you got negative 10, you've got an A to the first, B to the first, C to the first. Even though they are out of order, it doesn't change the fact that it's the same group of variables that have the same exponents. Okay, what about this last term? Yeah, that one's going to be different, so we'll worry about it here in a minute. Okay, so right off the bat here, the lead term, we have 23 ABCs. We have negative 4 of them. Then we have negative 10 of them. Let's see if we can figure out how many we got. 23 and negative 4. How much is that? That's 19. And then you take away 10 more. You have negative 19 minus 10. So a negative 19, I'm sorry, positive 19 and a negative 10. 19 minus 10, there are 9 A, B, C's. Exactly. Okay. And we have this one little term down here that doesn't match up to anybody. So it doesn't have anybody to add with, so we're just going to write him down. 3 ACs. And there you go. There's your answer. One more before we move on. Okay. This polynomial happens to have 5 terms, and it doesn't matter how many terms the polynomial has. It could just have 2, or it could have 102. Okay, the same rules are going to apply. And again, typically I just start off with the lead term. Okay, in this case it's RTs, and then I ask myself, are there any more RTs that I can combine with this one? Do you see any more? Okay, yeah. Here's one, actually a negative one. Okay, negative 1 RT. Any others? Yeah, the one on the trail term back there is also an RT. Again, they knocked it out of order, but it doesn't change the fact it's still an R to the first and a T to the first, so it's like terms. Okay, let's see how many RTs we have. Here there's positive 2 of them. In the middle, there's negative 1 of them. On the trail, there is negative 1 of them there. So 2, take away 1, down to 1. Take away another one, 0. 0 RTs. Okay, if there's 0 of them, do we even have to write them down in the answer? No. If they zero out, they're gone. We can forget about the RTs. We don't even need them in the problem anymore. Okay, then let's look at what else we have. Next term I see open is an S to the first. Any other S to the first to combine there? Yeah, there's one right there. There's 0 of them as well. 5 take away 5. Those are gone. Those are gone. So what do I have to write down as an answer? 0. Yep. That's one of those where our answer is there's nothing in the answer. Okay. So there you go. You just got to follow your rules. You got to have the same variable in this or the same group of variables with the same exponents. And if you have fractions, which we haven't messed with yet, you will have to have common denominators, just like always. Okay, moving on. Okay, those were the rules for adding and subtracting terms. It's a completely different set of rules if you are multiplying or dividing. But what you're going to find is that multiplication and division is far less picky than addition and subtraction was. Addition and subtraction had to have certain things line up in a certain way so that we could do it. Multiplication and division kind of happens almost whenever, but there are a few things that we need to remember. Okay, first off, when you are doing multiplication and division, numbers are going to combine with other numbers. Okay, so numbers are not going to join with x's to form purple carnations or any other goofy thing like that. Numbers are going to only combine with other numbers. The second thing will be that variables will only combine with their kind of variables. Meaning x's are only going to go after other x's. Even if the exponents are different, x's are going to go get other x's. Y's are going to go get other y's. C's are going to go get other c's. Gummy bears are going to go get other gummy bears. It doesn't matter. Okay, they are only going to seek out their own kind when it comes to multiplication and division. The next thing we need to watch out for, and the final thing we need to watch out for, is the laws of exponents. So again, if you did not bother to learn or practice the information from yesterday, it's not going to leave you alone. It's going to continue to cause you problems today because the laws of exponents are a big piece of information as far as multiplying and dividing. All right, let's look at some examples and see if we can figure out how this stuff is going to work. Okay, this is what we call a binomial. Binomial means it has two. The prefix bi means two. Okay, two terms. Okay, and they are being multiplied by each other. That's fine. Multiplication and division is easier than addition and subtraction. So let's see what we can do. The rule said that numbers were going to combine with other numbers. So when we look at the multiplication of two terms, okay, numbers go get other numbers. So here we go. We have some numbers right there, and we have some numbers right there. They are going to try to multiply with each other. 14 times negative 2, what's that? Yikes. If you have two 14s, what do you have? 28. Positive times negative will be negative. Our answer will begin with a negative 28 coefficient. Okay. The rule number 2 up here, guideline number 2 up here said variables will only combine with their own kind. Okay, well, x's right there are going to want to go get other x's. Now, as we can see when we look at that, we have different exponents on our x's, and that's why we have the laws of exponents. Those x's are going to join together. Okay, what kind of math happens to join them together? We have a base of x multiplying by a base of x. What do you do with the exponents when the bases are the same, multiplying together? Add them up. That's exactly it. So how many x's will there be in the answer? 1 plus 3 will be 4. There will be x to the fourth in the answer. Exponent of 1, exponent of 3, add them up. That's the first law for the laws of exponents. All right here, we have a y. What does y have to multiply with over there on the right? Yeah, nothing. So what is it going to do? It doesn't have anything to do. It's just going to show up in the answer. Okay, so just throw a y down there. And then lastly, we have some z's. And on the other side, we have some more z's. They are multiplying together, which means what do you do with the exponents? Add them up. Yep, that's right. You got z squared, z to the first, add them up, z cubed. And there you go. That is your answer. Negative 28, x to the fourth, y to the first, z cubed. That is how they multiply together. Let's look at another one. Oh, this one's a division problem. It looks different, but it doesn't change much. It's also got some multiplication in it. Okay, I'm going to erase the first example to give us a little room. All right, first thing, coefficients. Okay, numbers want to combine with other numbers. In the numerator, we got a 12. In the denominator, we got a 2. So we have 12 divided by 2. What is this? 6. Okay, so I'd write down a 6. Okay. What else do we have? We've got g squared in the numerator. What about that h to the negative 3? What does that mean? Negative exponent. Law number 4 from yesterday. Yeah, negative exponent means that that h does not want to be in the numerator. Okay, it doesn't belong there. So we're going to send it to the denominator. Okay, so it can be a positive 3. But hey, look, there's already h's in the denominator. Okay, so the h is coming down to the denominator. They're going to combine with the other h's that are down there? Sure they will. How many h's will there be in the denominator when these 3 drop down? That's right, there'll be 4 of them. So we'll have 4 h's in the denominator. We missed a number right off the bat when we went through. There was a 3 sitting in there also, so I'm going to put it back in the denominator. We hadn't done anything with it yet. And there's also a g in the denominator. So obviously we're not quite done yet. Okay, we still have some numbers that have not yet been combined. And if you look at the problem, you can see you have g's in the numerator and g's in the denominator. We'd like those only to be in one place. Okay, well, let's just deal with the numbers first. 6 divided by 3, what's that? 2. Okay, so got a 2 now. Okay, now we've got 4 h's in the denominator. Seems pretty unlikely that we're going to be able to do anything about that. Now, what about these g's? What is it? What's the rule when you have g's in the numerator and denominator of a fraction? They're being divided. Okay. Law number 2 from your laws of exponents says to take your numerator's power minus your denominator's power. So we have g2 minus g1. 2 minus 1 is positive 1. And we said that that answer will be in the numerator unless it happens to be a negative exponent, which would send it to the denominator. So g to the positive 1 is going to be in the numerator. The numbers are all in one place. The g's are all in one place. The h's are all in one place. There's no negative exponents. There's no zero exponents or any other crazy stuff like that. That's where we're trying to get to right there. Let's look at one more. Okay, let's take a look at this one. We have 3a's times negative 4b to the negative 2 times c squared times 5a cubed. Lots of stuff going on in there. Okay, but let's just work through it. With multiplication and division, numbers want to combine with other numbers. Let's take a look at our coefficients. 3 times negative 4. What's 3 times negative 4? Negative 12. Okay, negative 12. And that also multiplies by positive 5. Okay, does anybody know what negative 12 times positive 5 is? Okay, it's negative 60. Okay, it's negative 60. Okay, all right, let's take a look at what our variables are doing. We have some a's right there. Any other a's that'll want to multiply up? Yeah, we got some back there. How many a's will we end up with? There are 4 of them. A to the fourth. Let's look for some b's. There are some. Any other b's? No, I don't see any. So we got some b to the negative 2's. How about some c's? Just those? C squared. Is this good? Is this our answer? No, not quite. What's wrong? Negative exponent right there. Okay. Got to deal with that negative exponent. So negative 60 is okay. It's going to be in the numerator. A to the fourth is okay. It's going to be in the numerator. C squared is okay. It's going to be in the numerator. But what's going to happen with B? Yeah, B is going to the denominator. So we're going to end up with 60. A to the fourth. C squared. And in the denominator, here comes B. Now that it's in the denominator, its exponent is positive. So there you go, B squared in the denominator. All right, now the real challenge is going to come into when you have multiplication and division and addition and subtraction going on in the problem at the same time. Okay, but the only thing that this does is it makes you remember all your rules at once, but it also brings order of operations into play, which kind of should be a no-brainer at this point. Okay, we're going to go through, please excuse my dear Aunt Sally as we work through the problem. Okay, so let's take a look at the problem. All right, you see the big addition sign right in the middle of that problem? Okay, think about addition and subtraction as like a big wall blocking off the two different parts of the problem, the first half of it and the last half of it, until we deal with the addition on the, or the multiplication on the left and the multiplication on the right. We are not going to be able to deal with the addition that is in the middle. Okay, so let's just take a look. These two terms right here on the left-hand side, 3x squared y times 6y. Let's figure out what that's going to be on your papers. And also, let's figure out what 4 times 6x squared y squared is going to be. Okay, what you should have ended up with on that multiplication is 18x squared y squareds, which will be added to, if we can, 24x squared y squareds. Okay, that's the result of following the rules for multiplying terms that have variables. Okay, now we have an addition problem. We have an addition problem in there. Let's see, can we add these two terms up? On the left side, we have x squared y squareds. What can x squared y squareds be added with? Other x squared y squareds. So they can be added. How many are there? 18 here, 24 there. How many is that? 42. X squared y squareds. Okay, it doesn't get any harder. Okay, all they can do is put more terms in there. They can put more operations in there, addition, subtraction, multiplying, dividing. They might throw fractions at us. Okay, they can't make it any harder. If we know our rules, we can work it. Well, just one last problem. All right, well, let's take a look at this example. Okay, please excuse my dear Aunt Sally. But remember, one of the basics of order of operations, if you have a big fraction, like is what we have here, simplify the numerator as much as you can using your order of operations. Simplify the denominator as much as you can using your order of operations before you try to combine the numerator and the denominator. Okay, so let's look at the numerator. What would we want to do first in the numerator? That multiplication right there needs to be dealt with before the subtraction. Denominator, not really an order of operations problem because there's only two terms down there to mess with anyway. So in the numerator, we got 15 xy's. From that, we're going to subtract whatever comes out of this multiplication problem. Well, what does come out of that multiplication problem in the numerator? Yeah, 2x times 6y is going to be 12xy's. What about in the denominator? What's down there? 6 xy's, exactly. Okay? And again, we want to simplify the numerator as much as we can and simplify the denominator as much as we can before we try to combine from numerator to denominator. The numerator's not simplified yet. Can we combine these two terms? Yeah, you've got 15 xy's, and then you have negative 12 xy's. Those are common terms. How many xy's are there? 15. Take away 12. There are 3. All right, now it's down to a multiplication and division problem. Okay, so by multiplication and division, numbers want to combine with other numbers. 3 divided by 6. What's 3 divided by 6? Mm-mm. 1 over 2. Okay, 3 divided by 6, 1/2. Okay, 6 doesn't go into 3. It only goes halfway into 3. So we're going to end up with a 1/2 at least as part of our answer. Okay, we've got x's in the numerator, x's in the denominator. How's that work? Numerator minus denominator. X to the first minus another first. 1 minus 1, 0. What happens when something's raised to the 0 power? It's gone. Okay, so the x's are going to go away. That's a 1. What about the y's? Same thing, right? Y to the first divided by y to the first. That's 1 minus 1, 0. The y's are gone. What's the answer? 1/2. That's it. Sometimes these things will simplify all the way down. Okay, you've got an assignment. There's 10 questions on that, guys. You absolutely need to be practicing this stuff. It is not intuitive. It's going to take some work. It's going to take some practice, and you're going to have to get some rules memorized. So please work on it.